Hey, this is Presh Talwalkar. You open a brand new deck of cards. You notice the cards are arranged in increasing order by suit. You give the deck a proper random shuffle. The question is, how many cards on average do you expect to be in the exact same position as before you shuffled the deck? Give this problem a try, and when you're ready, keep watching the video for the solution. So we'll get started by asking, how many different ways are there to arrange 52 cards? You can arrange them in 52 factorial different ways, which is approximately 8 times 10 to the power of 67. This is an astronomically large number. If you were to count one arrangement of a deck of cards for every second of the age of the universe, you would still only count less than 10 to the 18 possibilities. So what this means is we're not going to solve this problem by counting out all the different arrangements. This also leads to a bit of trivia. If you give a brand new deck of cards a random shuffle, it's very likely, because there are so many different arrangements of cards, that you will end up with an arrangement of cards that no one has ever seen before. So now let's try and solve the problem. We'll first ask, how often is the first card going to remain in the same position? I'll call this the correct position. Well, the first card is equally likely to be in any of the 52 spots in the deck. So there is a 1 in 52 chance that the first card will be in the first spot. Similarly, it's equally likely that every single card will have an equal chance of being in the correct position. The second card has a 1 in 52 chance of being in the second spot, and so on. So to solve this problem, I'm going to define a random variable, x sub k, that equals 1 if the kth card is in the correct position and it equals 0 otherwise. This will allow us to define the problem in terms of these random variables. The question, how many cards do we expect on average to be in the correct position, can be redefined in the notation that we want the expectation of the sum of each different card being in the correct position. By the linearity of the expectation operator, this will be equal to the sum of the expectations. Now, how often will the first card be in the correct position? That'll be the same thing as the expectation of x sub 1. Well, we just reasoned that each card has a 1 in 52 chance of being in the correct position. So we figured out that the expectation of each different variable is equal to 1 divided by 52. So we can substitute the value of 1 over 52 for the expectation of each individual random variable. We now have 1 over 52 added to itself 52 times. Therefore, we have a sum that's equal to 1. And that's our answer. So this is actually surprising to some people. In a proper shuffle of the deck, we actually expect one card to be in the same spot as before. It's not true that in a random shuffle, every card will end up in a new position. We actually expect one card to remain in the same spot. Did you figure this out? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.